Afternoon, everyone. So welcome to the HKRE Civil Division Technical Seminar with the Hong Kong Polytechnic University Department of Civil and Environmental Engineering. So today the topic is lean duplex and ferritic stainless steel, the high performance and cost-effective options for structural applications. We are delighted to have Professor Huang to share her topic. So let me introduce her first. Professor is currently an associate professor at the Department of Civil and Environmental Engineering of the Hong Kong PolyU, and she received her bachelor and doctoral degree from the Department of Civil Engineering at the University of Hong Kong in 2009 and 2013 respectively. Before joining PolyU, she worked as a senior lecturer at School of Engineering in University of Edinburgh for about 10 years. She is an expert in structural behavior and design with research focused in light gauge steel modular construction, climate resilience of buildings and adaptation in vulnerable community and offshore energy infrastructure. Professor also serves as the associate editor for ASME Journal of Pressure Vessel Technology, at editorial board for Journal of Constructional Steel Research and Framework members, and Stability and Grant Committee of Royal Society in UK. So without further ado, let me hand over the stage to Professor for her to give the topic. Professor, please.
Okay, thank you very much for the introduction. Thank you everyone for attending this CEE webinar series co-organized with Hong Kong IE. So before my talk on stainless steel, I would like to first introduce our Department of Civil and Environmental Engineering. CEE is the short name for our Civil Engineering and Environmental Engineering Department. We have a high global recognition that we are very proud of. So we would like to introduce in the Shanghai ranking, we rank number 3, and which is number 1 in Hong Kong, and number 1 in transportation science and technology, number 44 for the environmental science engineering. For the QS ranking, civil and structural engineering, we rank number 17 in the world. And for the US News, we rank number 2 for the best universities for civil engineering. We also rank number 18 for the best universities for environmental engineering. Both are number 1 in Hong Kong. And we have, this year, we have 29 CEE colleagues ranked world's top 2% scientists. And here is the list of our colleagues. We also have many colleagues who are academicians and Changjiang scholars, including our president, Professor Jingguang Tang. And also we have Professor Anthony Chen, Guo Hai, William Lam, Professor Ni, Professor Poon, and Professor Xia are the Changjiang scholar. Professor Zhao and Professor Ahmed El-Kasoni are the fellow in Australia and UK respectively. We have achieved significant research input in the past few years, including the theme-based research scheme. We have Professor Ni, Professor Li, Professor Tang, and Professor Wang received a significant amount of research funding through this funding scheme. We also secured significant funding through the RGC Research Impact Fund and also Green Tech Fund and Collaborative Research Fund. And here is some of the significant funding schemes that we received in recent years. So our academic program, Civil Engineering and Environmental Engineering Department offered 3 different programs. For the undergraduate program, we have 2 degrees in civil engineering and also environmental engineering and sustainable development. For our bachelor degree in civil engineering, we also offered a second major in ADA, which is AI and digital and data analysis. And for our master program, we also have 2 degrees. One is Master of Science in Civil Engineering and Master of Science in Environmental Management and Engineering. And then we have research postgraduate program. We offered Master of Philosophy degree and Doctor of Philosophy degree. And I would like to also introduce some of our outstanding alumni. And here are the list of our alumni. We can see our outstanding alumni have been working in industry and government bodies. Yeah, so that is my short introduction about our department. Welcome to connect with us, and we look forward to collaborating more with the industry. And now I would like to introduce my topic, Duplex and Ferritic stainless steel, the high performance and cost-effective options for structural applications. So my webinar is designed to consist of 3 parts. The first part is about the applications of stainless steel in construction and comparison of different stainless steel types. And then the second part is about the mechanical properties and structural behavior of duplex and ferritic stainless steel under ambient and elevated temperatures. And we understand that recently the industry is concerned about the new materials applications in the fire scenario. So in this part, I will talk about the stainless steel behavior in both under fire situation and post-fire residual strength. And the last part is the design methods for new stainless steel grades in key structural components. So I will start with the first part is the applications and comparison. So stainless steel may not be familiar with many engineers in industry. So I would like to introduce why we need to consider using stainless steel. So cold form stainless steel sections have been increasingly used in architectural and structural applications, mainly due to its nice appearance, ease of maintenance, and superior corrosion resistance. So stainless steel is not only one type of material, it is actually a family of, actually in the market, you can find over 200 different stainless steel types. It is a family of corrosion and heat resisting steels that contains a minimum of 10.5% chromium. So this is basically the definition of stainless steel material that has 10.5% chromium. Stainless steel naturally will form a corrosion-resistant surface passive layer. That is why there is no requirement for applying protective surface in most of the cases. Typical stainless steel grades used in construction, including the 3 types that show on the screen, the 3 different types. So mainly duplex and austenitic are mainly widely used in Asia and North America. And in recent years in Europe, there are an increasing use of duplex and ferritic stainless steel. So they are newer grades of stainless steel in construction applications that I will talk about their applications later on. So the use of stainless steel in structural applications is mainly in the aggressive environments and architectural applications. You can see in these 2 photos, the upper photo shows the use of duplex 2205 stainless steel in Saudi Arabia. And as we know, structures in Saudi Arabia need to resist heat and sun abrasion. So they choose to use duplex stainless steel to provide a good maintenance. And then in Sweden, you can see a sculpture that uses austenitic stainless steel, mainly due to its architectural feature. You can see it looks very shiny and it looks quite nice. Also, we also understand the high initial cost of stainless steel is often offset over its lifetime, owing to the low maintenance requirement and excellent durability. So I will talk a little bit more about the cost consideration for stainless steel. So we all understand that the initial cost of stainless steel is high, But the high cost is mainly depend on the cost of nickel and also other alloying element. But the content of nickel mainly drive the high cost of stainless steel. And if we consider the whole life cost, all stainless steel materials are 100% recyclable without compromising properties. So that means all the stainless steel structures at the end of life cycle can be recycled and the properties will not change no matter how many times it is recycled. So SCI, Steel Construction Institute in the UK, did an analysis on the life cycle cost between stainless steel and painted carbon steel. So you can see here is a handrailing by the sea. Stainless steel at the initial cost is double of the painted carbon steel, but at around 15 years of time after the first maintenance, the carbon steel overall cost is already exceed the stainless steel. And then at the year 30, after the second maintenance, the lifelong cost of carbon steel is around double of the stainless steel at 30 years time. And then at 45 years time, it also requires another maintenance. So if we consider the life cycle cost analysis, it shows that stainless steel can be the cheapest option compared to materials requiring more maintenance. And we also understand the cost is not only about the initial cost, and also maintenance costs can be quite high. The maintenance costs include the material and labor, and also for some critical structures, the cost of shutdown during maintenance can be also quite high. So sometimes it is not possible to access the components. I will show you some examples later on about a nuclear plant that they replace carbon steel to stainless steel mainly because they cannot access the component for maintenance. And also the stainless, the studies have shown that the steel corrosion costs 3 to 4% of the global GDP and generate 4 to 9% of the CO2 emission. So stainless steel that can resist corrosion already provide a good consideration of cost. So as I mentioned, that stainless steel structures are almost maintenance-free. The good example is the first structural application of stainless steel in Chrysler buildings in New York. The first application is in 1930, and it has been only cleaned twice in history. It almost still in a perfect condition during cleaning, except for a few pitting. So we know that the Chrysler building in New York use alternative 302 and 304 that can provide a very good corrosion resistance. Here is the example of the nuclear facilities in the US. It was constructed using carbon steel before, and after during the maintenance, they realized that the maintenance is very costly. And then after the maintenance work, they decided to replace the components into stainless steel. The other example is the offshore or marine structure. And we are all familiar with the fourth bridge in Edinburgh. As mentioned by the host, I actually work in Edinburgh for around 10 years before I moved to UK. So the fourth bridge was constructed by carbon steel, and it requires regular painting in order to resist the corrosion. So one of the news in BBC says the painting project took 10 years. And it cost £130 million, which is very costly. So in the North Sea, So in the North Sea, we can see some of the offshore platform. They actually use stainless steel. Here is the example of the Armada platform. And stainless steel also have the advantage of energy absorption. So stainless steel has a much better ductility compared with carbon steel. And also the toughness of stainless steel is also higher than the normal carbon steel. So you can see this chain, actually the head of the chain, they use ferritic stainless steel to construct the structure. And during a clash accident, the stainless steel, because of the ductility, can absorb a lot of energy. So you can see the rest of the chain actually remain undamaged. So if we look at globally, the global applications, here is in Asia, the stainless steel applications include the famous Stonecutter Bridge in Hong Kong that we normally see. They use Duplex EN 14462. And then the Jinmao Tower in Shanghai, the BHP House in Brisbane, and the Petronas Tower, they all use austenitic stainless steel, 304 and 316. And also the Double Helix Bridge in Singapore use the same duplex grade as in the Stonecutter Bridge. So we can see austenitic and duplex are the commonly used stainless steel type in Asia. So in the US, the situation is similar. The Cloud Gate in Chicago, Gateway Arch in St. Louis, Chrysler Building in New York, and Walt Disney Concert Hall in Los Angeles use austenitic 304 or 316. For the Harbor Drive pedestrian bridge in San Diego, it looks very nice. They use the duplex 1.4462, same grade as our Stonecutter Bridge. So in Europe, as I mentioned, the situation is a bit different. So we need to pay attention that actually Northern Europe has a very advanced stainless steel manufacturer. So the best stainless steel products normally come from the Northern Europe. So I would say even the Euro code is more advanced compared to the rest of the world. And they are, I think they do a better job in terms of using stainless steel for their structural application. So in the Europe, you can see that Lin Duplex EN 1.4162 and 1.4662 have been used in quite a few bridges in Europe, including in Norway, Spain, Italy, and Sweden. And actually, they start using Lin Duplex from 2002 in Spain. And then in London, the Waterloo International Rail Terminal, they use austenitic. So we need to pay more attention about the increasing application of Lin Duplex. So I talked about there are many different types of stainless steel grades used globally. So how do we compare? How do we make the decision? So here I use the triangle of price, strength, and corrosion resistance to compare different steel grades. So in Hong Kong, we mainly use duplex and austenitic. So you can see the price of duplex is double of austenitic. It is very high, but the strength and corrosion resistance of duplex is also double of austenitic. So in terms of the cost to strength and cost to corrosion resistance ratio, these two grades are similar. So if you want to have a much better performance, you can pay higher for duplex, and then austenitic is a cheaper version. So then for the Lin Duplex stainless steel grade, so we can see it is the red triangle. Compare with duplex, so you can see the red triangle is much cheaper. So actually the price of Lin Duplex is almost the same as austenitic. And then the strength of duplex is double of austenitic because the strength of duplex is the same as Lin Duplex. So in terms of the cost to strength ratio, we can already see Lin Duplex is better than the existing duplex and austenitic. In terms of the corrosion resistance, we can also see Lin Duplex is somewhere between austenitic and duplex. So it also have a very good corrosion resistance that is suitable for most of the civil engineering applications. So that is why Lin Duplex has been increasingly used in structural applications. And then for the ferritic stainless steel, which is the orange color, so actually in European countries, they have been paying more and more attention about using a ferritic stainless steel. There are not many applications yet but they have been paying more and more attention, mainly due to the fact that ferritic stainless steel the price is only half of austenitic. It is actually quite economic efficient, but the corrosion resistance is of course not as high as austenitic, but still it will provide a good corrosion resistance in most of the cases. And also the strength of ferritic is higher than austenitic. So in my presentation, I mainly focus on lean duplex and ferritic stainless steel. I would consider them a cost-effective options and also high performance for structural applications. Okay, so if we look at the corrosion resistance in different classes, the higher classes offers the best corrosion resistance. So you can see that the duplex or super duplex is in here. So here, and also the stonecutter bridge, the duplex 1.4462 is not the highest grade, but it is the fourth grade. It is actually the highest corrosion resistance compared with the other commonly used stainless steel. So we can see why the stonecutter bridge want to pay more for the high cost duplex, because it do have a high corrosion resistance. Then for the lean duplex stainless steel, including the commonly used 1.4162 and 1.4662, it is at the third class, and then the ferritic stainless steel is here. So in terms of the corrosion resistance, we can see ferritic stainless steel. The second is austenitic stainless steel. Third is the lean duplex stainless steel, and the fourth is the duplex stainless steel. Okay, and I also put the comparison of Q960, which is the high strength steel, because I understand in Hong Kong, we also looking into the use of high strength steel more and more. So I also would like to put it as a comparison. So the price of high strength steel is around here. So it is still less costly than stainless steel, but stainless steel can provide the corrosion resistance that the high strength steel cannot provide. Okay, so this slide is also important in terms of the price, because as I mentioned that the stainless steel price is mainly depend on the nickel price. And nickel is a mineral that fluctuates very much. So imagine that if you use lean duplex and ferritic stainless steel, these two stainless steel have a much lower nickel content compared with austenitic and duplex stainless steel. So you can see lean duplex is only 1.5 of nickel. Ferritic is 0.5 of nickel, compared with austenitic and duplex has a much higher nickel. So when nickel price fluctuates a lot, duplex and austenitic will be influenced a lot, while lean duplex and ferritic, the price is relatively stable. This is quite important when we are considering the construction cost, because by the time that we are designing for stainless steel, if we choose austenitic, maybe we choose austenitic when the nickel price is low. But when we start constructing, when we start buying, when we start using the stainless steel, the nickel price becomes here, then our construction project cost will be much higher. So there is an uncertainty if we use duplex and austenitic, because there is uncertainty of nickel price. In comparison, if we choose lean duplex and ferritic, the price will be much stable. Okay, so I have talked about the comparisons. I hope you have a better understanding about different stainless steel types. And now I would like to talk about some applications of lean duplex stainless steel. So here is a railway bridge that constructed in Spain in 2011. So this lean duplex stainless steel was used due to its lowest life cycle cost, and it's actually reported. It actually reported that lean duplex is chosen because of the lowest life cycle cost, not because of anything else. So it's mainly because of the cost that this project chose to use lean duplex stainless steel. And then there is another example of a railway bridge in Sweden. So this railway bridge is the busiest railway bridge and it was actually originally fabricated by carbon steel, but they are now replaced fully by lean duplex stainless steel in order to reduce the maintenance cost and avoid the rail closure. So the comparison shows that using 120 years life cycle, the initial fabrication cost for carbon steel is 2 million, stainless steel is 4 million, but over 120 years, stainless steel repainting and repair cost is 0, but the carbon steel is 60 million. So this is a report that done by this Molly review. And then the New Doha International Airport, they have the largest stainless steel roof. And because this airport is close to sea and also need to resist heat, humidity, and salt corrosion, so they choose lean duplex over austenitic, mainly due to its higher strength and also allow the reduced thickness and lighter weight. So they did consider austenitic, but in the end, they choose lean duplex. Okay, so now I will move on to the second part, is the mechanical properties and structural behavior. So I would mainly focus on how stainless steel is different from carbon steel. So in my previous research work, I started working on stainless steel since 2009 when I was a PhD student. And then I realized that although lean duplex and ferritic stainless steel has clear advantages over the traditional duplex and austenitic grade, however, their mechanical and structural behavior as a structural component remain under research. And also for Eurocode 3 Part 1.4, they have amended in 2016. And during the amendment, Eurocode Part 1.4 actually added lean duplex stainless steel and also amended the ferritic stainless steel design, mainly because the available research result from the year 2009. So since 2009, there are more research, and the research output lead to the amendment of Eurocode 3, in particular on lean duplex and ferritic stainless steel. And also the research work is mainly about the material properties and the structural behavior. And also during these 10 years, there are new design recommendations proposed for structural members under various loading cases. So I will first talk about the lean duplex stainless steel rectangular hollow section. Here are some of the research that we did to understand more about the section properties and also the mechanical performance. We also are interested in the lean duplex stainless steel under high temperature. So we also did some high temperature, some coupon tests under high temperature up to 1000 degrees Celsius. So here is the result. We can see that if we plot the horizontal axis as the temperature and the vertical axis as the reduction of Young's modulus and the U strength, we can see that the current design rule, which is the red line and the dotted black line, cannot predict lean duplex stainless steel very well. So in our research, we propose a new curve specifically for lean duplex stainless steel. So using this curve, we can predict the reduction behavior, the reduction property under different temperatures. And we also propose design rules in order to predict the full stress strain curve for lean duplex stainless steel. And then for the post-fire behavior, we are interested to know what is the behavior of lean duplex and ferritic after fire exposure. So we did experiments to look at the microstructure and also the hardness after it has been exposed up to 1000 degrees Celsius, and we can clearly see the behavior is different. And then so you can see these dots are our test result. And then the other lines are the existing design rules for other material. So you can see the dot, these lines, the red dot is lean duplex, the black dot is ferritic, So both ferritic and stainless steel, after exposed to 1000 degrees Celsius, there is no change of Young's modulus. And then for the strength, lean duplex stainless steel do not reduce, but the ferritic stainless steel after exposure, it actually go up. It do not reduce, but it actually go up by more than double of the original strength. So this is quite impressive. So you can see the other carbon steel materials, S460, S690, G300, they all reduced, the property all reduced after exposed to high temperature. So we also look at different cooling method. We can see different cooling method have little effect on the lean duplex and ferritic performance, and we also propose a stress strain curve. And then for the member behavior, we conducted experiment and also numerical analysis to look into column beam and beam column members under ambient elevated temperature and post-fire condition. And then for the tubular joint, we did a very similar thing, mainly to look at the lean duplex and ferritic stainless steel. And then our test and numerical results are compared with the existing international design guidelines, including the American, Australia, and New Zealand, and Eurocode. And the conclusion is that all the international design guidelines are actually quite conservative for lean duplex specimen, which need to improve. So that is why after our research, we proposed some new coefficient for lean duplex stainless steel. So this is our proposed coefficient on top of the Australian standard. And we compare our test to design ratio, and we realize our modified proposal is provide a less conservative than the existing one. And we also did the same thing for Eurocode 3 Part 1.4, that we propose a new class 3 limit for lean duplex stainless steel. And then for the American specification, we proposed new parameters for lean duplex stainless steel in predicting the buckling behavior. Okay, so now I will move on to the last part, is the design methods for new stainless steel grade in the key structural component. So in this part, I would mainly like to talk about the development of the design rule in order to adapt the new the use of stainless steel. So our Hong Kong code currently still do not include stainless steel structural design, and then the American specification already include austenitic, ferritic, and normal duplex, but still they do not have lean duplex grade. The Eurocode is the most comprehensive because, as I mentioned, Europe is quite advanced in terms of stainless steel production. So their design code has lean duplex stainless steel grade and also the ferritic stainless steel grade. So I will mainly talk about the development of Eurocode 3 Part 1.4. So this is the framework of Eurocode, and the design of steel structure is here. And then the design of stainless steel is here, is Part 1.4. So the good news about stainless steel is that we understand the Eurocode, it has been undergone the second generation since 2021. And then the stainless steel is Part 1.4. The good news is that by the end of 2024, the second generation of stainless steel structural design has already completed. So if the company would like to use lean duplex stainless steel from this year, we can refer to the latest version of Eurocode 3, which is very timely in using the new design rule. So Eurocode was Part 1.4 has an older version of 2006. In this version, there is only ferritic austenitic and duplex stainless steel. There is no duplex stainless steel at all. In 2020, there is an amendment that new lean duplex stainless steel grade are added. So in the amendment, Eurocode did not add any other grade. They only add lean duplex stainless steel grade because in Europe, they see the potential of lean duplex in structural application. That is why they add more lean duplex stainless steel grade. And then in the second generation, in 2025, which is the latest version, they removed ferritic and austenitic grade that not commonly used. They only leave this austenitic and ferritic grade. Instead, on top of this, they even add 2 more new super duplex stainless steel grade in the second generation. So we can see the trend of structural design is that they are paying more and more attention in lean duplex. And the same thing is for the fire design. So for Eurocode 3 Part 1.2 is the fire design for steel. In 2005, they only have this grade. And then in 2024, in the second generation, they added 4 new lean duplex stainless steel grade. They didn't add anything else. And then we can see from the fire design in the latest version that stainless steel actually have a very good behavior compared with the carbon steel under fire. So you can see for the Young's modulus, both stainless steel grade have a much better fire resistance than the carbon steel. While for the strength reduction, before 600, the stainless steel grade degrade quicker, but only around 20% loss. But after 600 degrees, the carbon steel will degrade much quicker than the stainless steel. So at the higher temperature, stainless steel still have better fire resistance than the carbon steel. And then in terms of the structural design, what is the difference between the different steel grade? In the second generation of Eurocode, they actually newly introduced strength hardening region for the stainless steel. So in the past, the strength hardening behavior of stainless steel was not included in structural design, which is conservative for stainless steel. But in the second generation, they added the strength hardening using this strength hardening factor C1, C2, and C3. So in conclusion, the strength hardening effect, if we include this in the structural design, austenitic is the best, and then followed by duplex and ferritic. And then for a steel member, we always concerned about buckling. So we understand in the buckling curve, the higher the alpha ratio, the lower the lambda ratio, the weaker the buckling resistance. So in terms of buckling resistance among different stainless steel grade, we will compare the alpha and the lambda ratio. So in the oldest version, 2006, again, there is no difference between buckling resistance among different stainless steel grade. So you just pick any stainless steel material, the buckling resistance will be the same. However, in the amendment, the buckling resistance for ferritic is different from austenitic and duplex. So austenitic and duplex use one buckling curve. Ferritic use a different buckling curve. And then for the new generation in 2025, austenitic, duplex, and ferritic, they all use different buckling curve. So that means the buckling resistance, if you choose different stainless steel type, will be different. So your buckling resistance need to be calculated based on which stainless steel grade you choose. So after comparison, we realized duplex has the highest buckling resistance. So if your member is buckling sensitive, then duplex will provide the best performance, while austenitic is prone to buckle under compression among these 3 types. So the last part is the lateral torsional buckling under bending, which is we will concern about the beam design under buckle. So in the older version, up to 2020, there is no change in Eurocode 3 that all the stainless steel grade use the same imperfection factor for LTB. And then for the latest version of 2025, we can see that austenitic, duplex, and ferritic use different imperfection factor. That means the buckling LTB resistance need to be designed separately based on the steel grade that you choose. And overall, again, Duplex has the highest LTB resistance, and Austenitic is the weakest in terms of resisting LTB. So that is all for my presentation. Thank you very much for listening.
But for Professor's a wonderful presentation. So we have some questions from the audience. So let me um, ask some first to the professor. The first question is about the corrosion rate. So about the corrosion rate of the stainless steel, including the lean duplex, and also the authentic in the Hong Kong environment, and also whether it can serve for the design life and service life of 50 years in Hong Kong. Professor, please.
Yeah, so the corrosion rate really depend on the environment of the structure and also the loading condition. So it is very difficult to define which corrosion rate for a different stainless steel type. But overall, if you are for lean duplex stainless steel, if you look at the report for the Spain rail for the Spain footbridge, they classify that the design life is 130 years without maintenance. So that is I think they come up with this 130 years based on the corrosion rate in the environment. So that is a footbridge. And then for the railway bridge in the Sweden, you also can look at the report that actually the bridge is over water, is on top of water, and according to the report, this lean duplex stainless steel bridge does not require maintenance over 120 years. So I believe it should work fine in Hong Kong scenario, but I think maybe more research or literature review need to be conducted in order to confirm, like based on the environment and based on the loading condition.
So we have a question from the audience. Is the lean duplex and ferritic stainless steel available in Hong Kong market?
Oh yeah, we can. There is no local manufacturer for these two stainless steel grade. There are manufacturers in mainland China, and also we can also buy from Singapore, because Singapore is a distributor for some of the stainless steel manufacturer in the North Europe. So we can ship from Singapore. Yeah, I'm not sure about any Hong Kong distributor, but from my understanding, we can buy from Singapore.
So, Professor, do you think what are the direct effects of using the new stainless steel grades on academia?
What do you mean, academia? What do you mean that I don't understand the question?
Yeah, maybe the audience asking the question, can you type or retype the question again
I
for
cannot see the
us?
question on the screen. So
But you can see there is a Q&A box. Can you see the Q&A box?
yeah. Now I
Panel,
can
yeah.
see the Q&A box. Yeah.
So we finished the first few questions.
Direct effect of using new stainless steel grade on academia. I don't quite understand about this question.
Never mind, maybe we can move on to the remaining question first. So any welding constraint for different stainless steels?
I assume the attendance is asking about two different types of stainless steel. So there is, from my understanding, there is no welding constraint as long as they are stainless steel. But I don't see hybrid stainless steel structure in the past. So, for example, austenitic welded on duplex, I didn't see this scenario, but that there will be definitely welding constraint if we are welding stainless steel onto carbon steel. So it is difficult to weld stainless steel onto carbon steel, but stainless steel on stainless steel should not be a problem.
Move on to the next question. If we are going to use the welding connection, does it require different type of welding material for different stainless steel grade? And is the welding strength compatible to the steel strength?
Yeah, from my experiences, because I also conduct research on the welded tubular joints. If you look at my slide at the beginning, there are also some pictures of the welded tubular X joint and T joints. So we use the welding material that has a higher grade than the base material. And the welding procedure is fine. We actually welded in Hong Kong, a workshop in Hong Kong. So there are some local welders that is able to perform the welding, and the performance is also very good.
So we have two questions from Mr. Ke. Maybe you can answer in one go. The first question is about the fire-resistant coating for the stainless steel material, and he also asked about whether the professor did you try to convince the government to accept the material and also amend the code and practice to incorporate it into our new as our new code and practice.
Uh, for the fire resistance coating, I believe if Duplex stainless steel is used internally, then fire resistance coating will be required because it is not fire, the strength will still reduce under elevated temperature. So I believe the indoor use inside the building requires fire coating. The external use may not require fire coating. And then did try to convince government office to accept this material. That would be great. That I would like to work together with industry to convince the government officers to accept this material because there is a great potential, and you can see actually Eurocope start adding Duplex stainless steel from 2020, and every amendment they have been adding more new Duplex stainless steel grade. So I would see Duplex stainless steel is definitely the future trend, and also the price of Duplex is reducing. So later on when we are using Duplex in the future, it must be, I would expect it is cheaper than we are using Duplex now.
Due to time constraints, so maybe come to the last question. So what is the rust-resistant characteristic of lean duplex under salty conditions?
I
From
don't have this information at my head right now, but I think I need to check. Yeah, but Duplex stainless steel is suitable to be used in marine environment, depending on the application.
okay, thank you, Professor, for your presentation and also for the Q&A session as well. Thank you all the audience to attend our presentation, and we look forward to seeing you all in our coming technical seminars. So thank you all and good evening and bye.
Okay, thank you.